On to problem number 3 of the 2006 MIT Integration B finals. This is an interesting problem. A definite integral from x equals to 0 to x equals to pi of sine of 21 over 2x over sine of x over 2. So this is actually a problem that exploits knowledge on what we call the Dirichlet kernel. And it may have been hard to solve it if one didn't know that. So we'll go and begin just a methodical process of trying to develop that relationship before we actually do the integration. So I hope you enjoy and you stick around as we solve this problem. And try and see how we may solve this problem. So first, let's pull out the integrand, sine of 21 over 2x over sine of x over 2. So sine of x using Euler's expression is the same as e to the power ix minus e to the power negative ix over 2. And that's what we've done here. Sine of 21 over 2x is the same as e to the power I 21 over 2x minus e to the power negative I 21 over 2x over 2. Similarly, sine of x over 2 is the same as e to the power ix over 2 minus e to the power negative ix over 2 over 2. Now, the 2's would cancel and the relationship is transforms into e to the power I 21 over 2x minus e to the power negative I 21 over 2x over e to the power ix over 2 minus e to the power negative x over 2. If we pull in the denominator, not the numerator, if we pull in the numerator e to the power negative 21 over 2x, we can remove the halves, but let's express 21 over 2 as 10x plus 21 over 2x over as 10x plus x over 2, and then go and do what we thought we could do. So we pull out e to the power negative I 10x plus x over 2, and then the denominator we pull e to the power negative ix over 2. As we can see, the numerator on the second part, we've got to leave an extra e to the power I 10x plus x over 2. Similar in the denominator, we have to put this extra e to the power ix over 2. And we can see that this part here cancels with, we can see that this part here would cancel with this part here, right? And so we are left with e to the power negative I 10x, and then this extra x over 2 apologies, so instead of we have, this becomes 21, 10 plus 10. Okay, so we have e to the power I 21x minus 1 over e to the power ix minus 1. So let's stop here for a moment and analyze this relationship here. We have an initial e to the power negative I 10x, and then we have e to the power I 21x over e to the power 21x minus 1 over e to the power ix minus 1. If we look at the geometrical progression, if we have a summation of this geometric series a to the power r to the power k, where k starts from 1 to n, it is for r greater than 1, we have a times r to the power n plus 1 minus 1 over r minus 1. And that is exactly what we have here, right? So what that means is that we have a summation from k equals to negative 10 to k equals to 10 of e to the power ikx. And we can play around and say, okay, what about if we sum from negative 10 to 1 of e to the power ikx? And then we have the 0 component isolated, and then we have summation from k equals to 1 to 10 of ikx. Then it means that we have a problem that has 1 in between there, and we can isolate that 1, and then we have a summation from k equals to negative 10 to 1 of e to the power ikx plus summation from k equals to 1 to 10 of e to the power ikx. We can now set that k prime b equals to negative k, and so eventually we have the summation from k equals to 1 to 10 of e to the power ikx plus the summation from k equals to 1 to k equals 10 of e to the power ikx. So this allows us to now combine these two summations. So we have 1 plus twice the summation from k equals to 1 to 10 of e to the power ikx plus e to the power negative ikx over 2. So this here, using Euler's integration, is the same as the cosine of kx. So we have 1 plus twice the summation from k equals to 1 to 10 of the cosine of kx. We can now integrate from the integration from x equals to 0 to x equals to pi of sine 21 over 2x over sine of x over 2 is the same as the integration of 1 from 0 to pi, and then the integration of the summation of 2 of twice the integration of twice the summation from k equals to 1 to 10 of cosine of kx. And since we can pull the integration into the summation sign, this is the same as the integration of 1 plus twice the summation of k equals to 1 to 10 of the integration from x equals 0 to x equals to pi of cosine of kx. So from here we see that we have x as our integration with the limits 0 and pi, and then twice the summation from k equals to 1 to k equals to 10 of 1 over k sine of kx, and with the limit 0 and pi. So this first part is the same as pi minus 0, and the second part is twice the summation from k equals to 0 to 10 of 1 over k of sine of k pi minus sine of 0. So if k is an integer, which it is, so sine of an integer times pi is going to be 0. So this is 0. So this is 0. And this is 0. Okay. And so this becomes pi plus twice 0. And so which becomes just pi. And so the answer here, or the integration from 0 to pi of sine of 21 over 2 x over sine of x over 2 is going to be equal to pi. So we're going to just summarize by pointing out what a Dirichlet kernel is. And the Dirichlet kernel, denoted by dn of x, is the same as this summation from k equals to negative n to n of e to the power ikx, which we have shown to be 1 plus twice the summation from k equals to 1 to n of the cosine of kx, which equals to the sine of n plus half x over sine of x. And this is where our integrand was trying to test our knowledge of. I hope this kind of drives the point home for us, and it adds on to our bag of tricks when faced with such a problem. Until next time, have a great time, be blessed, and yeah. Stay locked.